Is it recording? Yes. Okay, so let's look at the first example here. We have barium sulfate, so we know barium. And this is going to be sulfite, so I need to look on my polyatomic ion chart. Let me get this right back. Okay, so if you look on your polyatomic ion chart, you're going to go to, where is it? SO3 right here, which is sulfite. And again, no Roman numerals because barium is in group 2. All right. Those should be fairly easy to do. Hold on, I'm trying to find my periodic table. I don't know where I put it. Where's the polyatomic ion chart? Okay. Alright, so the next one. If we look at this one here, obviously we got a polyatomic ion here and we've got a polyatomic ion there. So what I need to do, and again these are all, both, this is going to be an ionic compound because these are nonmetals. This was ionic. Okay. This one is also going to be ionic. Actually, for this worksheet, go ahead and determine if it's ionic or covalent. I would like you to do that as well. Okay, so this is barium sulfite. Here we're going to look for, in this case, we've got ammonia, which is here. And what does she need? Look at my first row over there. Okay, that's ammonia. And we're going to come down over here. PO4 3 minus is phosphate. I don't know if you can see those. Let me zoom in for a second. Okay, so you can see that that's phosphate. All right. So, that being the case, we would just call this ammonium phosphate. Now, because this is a polyatomic ion, we don't change that ending. So I said normally you're going to change those endings to "ide," but in this case you're going to leave it as ATE, okay? Now if we look at number 3, what you're going to notice on number 3 is that we've got phosphorus, and we've got bromine. So if I look at my periodic table, I've got phosphorus here. Can you see that? Yeah. And I've got bromine here. Okay, that being the case, both of these are nonmetals. So if they're both nonmetals, this is going to be covalent. So if this is covalent, we have to name this using the other rules. So this would be, we have one phosphorus. So this would be phosphorus. Remember, we don't need to put the mono because it's the first one. So it'd be phosphorus, and then we need to have penta. Now, it would be bromine, right? It'd be INE, but we changed the ending to IDE, okay? So this would be phosphorus pentabromide, right? Let's look over here at number 14. What we have on 14, this is going to be a metal. This is a polyatomic ion, so this is going to be an ionic compound, okay? So this is silver. And if you look at your polyatomic ion, well, if you look at your ion chart here, we find silver is right here. Okay, this is your periodic table. Silver's here. So it's in your transition metal. So we don't actually know what the charge on it is. This periodic table tells you that it's a 1+ charge, and silver is always a 1+ charge. But if you didn't know it, you'd come over here to your polyatomic ion chart, and you would see that silver is in the group where it's 1+. So because it's, you could write silver 1, and then the end here, we're going to look at this, and we're going to come down to your -1 groups, and we find nitrate is right there, NO3 minus. So this would be silver nitrate. And again, we don't have to have this one in here, so you can just actually scratch that part out. Next one, we have AS. AS is arsenic. It is here. It's going to be one of our nonmetals. The other part of it was oxygen, again a nonmetal. So this compound is going to be covalent. Okay, and so we would name this diarsenic. I wonder.
Oh, Jimmy? It's when I was like in 3rd grade.
It's actually a metalloid. I'm not gonna call this that. We're gonna call this is actually gonna be an ionic compound. I made a mistake there. Again, it's because it's actually a metalloid, it's touching these, but it's gonna be an ionic compound. So it's gonna be a metal. So this is going to be arsenic oxide. Okay. And if I was to uncross these charges, what you would see is that this would be AS 5 plus and O2 minus. I don't know if you guys remember that, but that's how we figure those out. And it's going to come into play when we talk about this compound here. So in this case right here, we have iron oxide. This is going to be an ionic compound because, again, we have a metal and a non-metal. If we look, iron is here, is a transition metal, okay? The charge on it here says it's a 3 plus. If you look at your polyatomic ion chart, you'll see that we have iron as 3 plus. We also have iron as a 2 plus, all right? So in this case, how do we know which one it is? Well, if you uncross your charges, so we have Fe2O3. We know that this 2 came from up here, this 3 came from here, so this would be iron 3 plus O2 minus. So this would be iron 3 oxide. Okay, can you see that? I'm writing. Nope. Okay, sorry. So we had iron, we uncrossed these, this was a 3 plus, this was a 2 minus, so this is iron 3 oxide. All right. I'll do a couple more, and then the rest will be yours to do. Let's look at next one's here. Okay. Yeah, I'll put this up. We have MgSO4. Mg, magnesium, is a metal. This is a polyatomic ion, so this is going to be an ionic compound. We know that this is magnesium. SO4, you're going to have to look on your polyatomic ion chart. So pull that over here. If we look right here, SO4 is sulfate. So this is going to be magnesium sulfate. And again, we don't change the ending. We don't change the ending of your polyatomic ions. This right here, this is going to actually be an acid. And the reason we know it's an acid is because it has this H right here to donate. But you could also say that this is a covalent compound. And the reason it's covalent is because these are all non-metals. So in this case, we want to look for ClO. All right, if we look for ClO, it's right here. Can you see that? No. Where is it? Yeah, I just put it right here. Okay. So this is hypochlorite. So this would be hydrogen monohypochlorite. When you have ITE with acids, you're going to change the ending to ic. So this would be hypochloric acid. So you don't worry about the hydrogen part of it. So it'd be hypochloric, and then because this hydrogen means we have this hydrogen and proton to give up, it's going to be acid. And we'll talk a little bit more about acid naming later. But just to give you a general idea, you can name it either way. All right, next one. All right. This is going to be ionic. We have a metal and a non-metal, so this is going to be calcium oxide. Here we've got non-metal, so this is going to be covalent. And so we're going to name this dinitrogen trioxide. Okay, IDE ending. All right. These are all nonmetals, so we can say this is covalent. Because we've got these H's here, this is actually going to also be an acid. So in this case, this is going to be, you can name it two ways. You can say this is trihydrogen monophosphate tetraoxide, or we're going to call this, because this is a phosphate, okay, this PO4 right here, if you look at your polyatomic ion chart, you can see that we have the phosphate over there. Because this is a phosphate, we would change the ending, okay, and we would get phosphoric acid. And again, the acids we'll go over a little bit later. This one as well, covalent. It's going to be an acid as well, because we have the H plus here. You can call this hydrogen monofluoride or hydrofluoric acid. Like I said, we'll go over the acids a little bit more later. All right, so go ahead. The rest of those are yours to finish. And we'll look down here at the bottom of this. So we're going to go through some of the this naming. Okay, hydrobromic acid. Okay, this is just going to be HBr. Bromine, bromic, hydrobromic acid. Okay. Over here we've got diphosphorus pentoxide. So diphosphorus means we're going to have, di means 2, phosphorus P, oxygen, and the penta means 5. All right, let's go to the next one. All right, that 3 right there tells me that I've got chromium, which is a 3+. Carbonate, the 8 ending on it tells me this is a polyatomic ion, which means I need to look at my polyatomic ion chart. And because we know that this is a 3+, we look over here. Let's see, where's chromate? Carbonate, sorry. Carbonate is here. Okay, so this is CO3 2-. So we got CO3 2-, okay? Now, this is where your crisscross rule is going to come in. So I'm going to cross here, I'm going to cross here. So you get Cr2, CO3, 3. Remember to put your parentheses, because what we're saying is that we actually have 3 of these groups, okay? So it's important that you put your parentheses there. Sulfurous acid is going to be HSO3, H2SO3. And we're going to go through those, so don't worry so much about the acids. Magnesium sulfide, so magnesium, Mg. We know that this is a 2+ because it is in, find this, magnesium is here, group 2, so we know that is a 2+. Sulfide, ide ending tells me that it's sulfur, that is a 2-. When we cross these, we get Mg2S2. And again, because these are both 2s, that means for every 2 magnesiums, you need 2 sulfurs, which means you need 1 for every 1. So remember, you can reduce to the lowest whole numbers as long as you're not reducing a polyatomic ion. And then we come over here, we have lead 2. So that means we're Pb2+. Nitrate, you know, is on your polyatomic ion chart because it starts with 8. It is NO3 1-. We're going to cross these. You get Pb. This would be a 1 here. We don't need to put it. NO3 2. Okay. All right. You should be able to finish the rest of those. We can do one more example here. Iodine trichloride. So you're gonna have iodine and 3 chlorines. Di meaning 2, hydrogen, H2, O, monoxide, or water. Okay. All right. So you guys should be able to finish the rest of those on the naming chart.